Here's another example of a division of rational expressions. When we divide with fractions, we turn it into a multiplication problem where we multiply by the reciprocal of the divisor fraction. So I need to first rewrite this as a multiplication. The first fraction remains unchanged. And we take the reciprocal of the second fraction. So the denominator becomes the new numerator. The original numerator becomes the new denominator. And now we're multiplying these two fractions. We want to cancel first. The only way we can cancel is we have to get these polynomials in their factored form. I can't cancel those 3x squareds because they're tied up with subtraction and addition. We can only cancel when the quantities we are canceling are factors, which means they are multiplying, not adding and subtracting. Couldn't cancel the 2x squareds there either. Couldn't take the 6 into the 12 there. No, those are combining by addition and subtraction. We can only cancel when it's multiplication. So I need to factor all of those trinomials. Well, let's start with this trinomial. A minus and a plus in the trinomial comes from binomials that are two subtractions. 3x times x would make 3x squared for me. And now I need to pick a factor pair of 8 that can somehow make a 10 for me. How about putting the 4 here and the 2 there? 4 times 2 would be 8, so that would give me the plus 8. And the O of FOIL would give me minus 6x. The I of FOIL would give me minus 4x, and those two combine to minus 10x. So we've gotten started. We've got one factorization there that works for that trinomial. Now, let's move down here. There's a 3x. There would be a 3x factor of this trinomial, wouldn't there? So let's see if it's 3x minus 4. Well, if this is minus 4, then doesn't this have to be plus 4 so that the L of FOIL would give me minus 16? And so this would be x. And will this arrangement give me plus 8x? 3x times plus 4, that would be plus 12x, wouldn't it? And minus 4 times x under the I of FOIL would be minus 4x. And plus 12 minus 4 combines to plus 8x, doesn't it? So instantly I can see my first cancellation. The 3x minus 4 factors cancel to 1. See, I can cancel now because this is multiplying here, isn't it? I can cancel now because that's a factor. Now, wouldn't I like to have x plus 4 to be a factor of that trinomial? I don't know if it is, but I'm going to try it out and see. It has a possibility because minus 3 times plus 4 would make minus 12, wouldn't it? Then that means that this would have to be 2x, so that x times 2x makes the 2x squared under the F of FOIL. Do the O and the I of FOIL work here? The O of FOIL would give me minus 3x. The I of FOIL would give me plus 8x. Plus 8 minus 3 is plus 5x. That worked. So the x plus 4s can be canceled. And what I'd really like to have happen is I'd like 2x minus 3 to be a factor of this trinomial. And there's the possibility, isn't there? I've got 2x squared here, so I need a 2x times an x. Oops. If I'm going to have plus 6, I've got to have two subtractions. So that's minus 3, which came from there, times minus 2. Oh, that's interesting. If this works, what's going to happen? Well, let's see. What have we got? Minus 4x for the O of FOIL, minus 3x for the I of FOIL, minus 4 minus 3 combines to minus 7x. And look what happened here. X minus 2 cancels the x minus 2. Remember, what are they canceling to? They're not canceling to 0, they're canceling to 1. And the 2x minus 3 over the 2x minus 3 cancels to 1. So what's left? 1 times 1. Even though it didn't look like it, the division of those rational expressions gave us an answer of 1. Now that doesn't happen very often, but it was kind of neat that it did.